Okay, guys, we're going to be looking at the BMP Monster, small block Ford. It's going to be going on a 393 with the AFR Enforcer clone heads that have been cranked up to a 208 intake valve. I'm not 100% thrilled with the valve job on the 208 because the insert just makes it. I mean, if you take a look, where is it? Oh, I still got the springs on and stuff on it. But even brought out, see, on the screen, it looks like I got plenty more to go. But I'll have to look at it. Sometimes it's good to look through the camera at things, because I thought I was right at the edge of the inserts. Yeah, there's no insert hanging over the edge of that valve. I have to look at that. If I have to shrink that valve size down a little bit to do a better valve job on the valve itself, because right now it's very high on the valve, and I'm not thrilled with it. So I know I'm losing some CFM right there. So I need to work on that a little bit more. A couple of the other things we need to take a look at is the top of this plenum has been modified. I don't know whether the customer modified it or you had somebody else do it, but they did a pretty good job. And I didn't really change it much. It's still a Holly. It's still a Holly bolt pattern. It hasn't been changed over, but it looks more like a Dominator size. It's I measured it, now I forgot. I think it's 1.5 inches bigger than the Holly both ways. But I did some testing with this spacer to see what would happen. And if you take a look, see if I can line it up. There's a huge overhang around the whole thing, right? Now, can that huge overhang be an advantage depending upon what you're doing? If you know anything about refrigeration, I don't know how many of you guys do, but we'll do a little bit of theory. How a refrigerator absorbs heat, right? That's really what it does. It's absorbing the heat on the inside where the food is, and it's blowing the heat outside the container, okay? Your central air conditioner does the same thing. The air conditioner in your car does the same thing. It'll do the same thing. So what we do is in the evaporator is evaporating the refrigerant. What you're doing is you're putting in a high temperature, high pressure liquid into a low pressure, low temperature coil. So what it does is it instantly evaporates. Okay, because of the low pressure, it instantly evaporates. And when it evaporates, it absorbs heat. That's how you take the heat out of whatever you're trying to take it out of, whether your house, your refrigerator, your freezer. It's all the same thing. Now, how can we take that and apply it to this? Well, if we use a step, right, from this Holly 2-inch spacer to the much bigger plenum, what'll happen to the pressure as the air goes past that rigid edge? The pressure would rapidly drop. What would happen to any fuel during that pressure drop? It can instantly evaporate and absorb heat. So that's one way. That is one of the reasons I think, and this is just my opinion, it don't mean anything, why a lot of these manifolds are designed with the big scallops, and guys machine it out to be open, and it makes more power. That's why I think it makes more power. Now, the customer says he's got a spacer, and he's definitely going to run nitrous on this, so I'm going to have to do a little. I'm thinking of what I should do on the chamber. I am not a nitrous expert, so some of you nitrous experts could really give me a hand on what we need to set the quench at, because we know this had detonation issues. So the airflow is going to be up by quite a bit, and he's going to be hitting it hard with nitrous. So we need to do whatever we can to prevent it from blowing apart. Now, I don't know if the spacer he has is going to be, machined to the edge. You can also, the other way to do it is you take the spacer like this and you blend it into the manifold. Blending it into the manifold would need to be tested whether it makes better airflow or not. I really don't know. It'd be interesting to see. So I did airflow tests with the intake bolted on the cylinder head, and then I did it with this spacer bolted on, and I used clay around it, both of them, and then I bolted on my 770 carb on them. So let's take a look at those three different flows and see what we got. Okay, so we've got the bare head here. We've got the intake here, and we dropped quite a bit. I mean, at 500 we go from 282 to 269 and change, right? From 300 to 288, which isn't bad, but I knew looking at that intake manifold, I remember I mentioned it to someone. I said, I bet it flows 350 stock, and I'll bolt it on the head and it'll knock it all the way down to 250. Well, it's not quite that bad, but it flows pretty close to 250. 250. 350. Okay. So I took these, and then I don't see 3. I only see 2. We've got other numbers here that we added the carb. It's got to be, okay? So from 269, you lose a few CFM to 264. And I know I did that with the 2-inch spacer on there. So, okay. So from 288, you lose a little bit. It goes to 281.3 with the carb on it. Now, he also has 2 different carbs he's going to run. He's got an 850 with down leg boosters. He's got a 950 with down leg boosters. As soon as I hear down leg boosters, I think leave that rough texture. We'll leave that as a question. Why would we want rough texture with down leg boosters? Because if he had annular discharge boosters, I would use a smoother texture. You guys can give me a little feedback on that. Okay, here, I wrote it down here. Last 3, 2-inch open and the 770. Okay, I made myself a little note so I know what I did. Okay, so from 281.3, which is if I don't touch the cylinder heads any more than and which I know I'm gonna work on that intake valve a little bit more. Try to get it. I'd like to do a little better than this, but I got a lot of time into these already. I went on to Wallace Racing, and they say as it is, it's good enough for 578 horsepower between 59.54 RPM and 74.54. And since he's going to be hitting it with spray, that's going to be a pretty damn quick ride. I don't know how much more I need to do. I definitely do have to work on the chambers because we don't want a detonation monster. We got to work on the quench. I did do some more work on the exhaust. Let's take a look at that. I didn't put the pluses and minuses, but I know it did a little bit better towards the top. It's only got one. It's got one spot at 0.15 that it was a little bit noisy. As good as the exhaust is, I would like to get it better for nitrous use. Give me some feedback on an exhaust port this good. If you're a nitrous guy, take a quick look. Take a look at our intake exhaust ratio, and let me know what we need to work on. Like I say, guys, I'm not a nitrous expert, so I could use some input on this. Let's take another look at the intake, and I'll show you how I equalize that. Okay. If you take a look, all right, the port on the right, which is number 1, has a much bigger radius around the plenum going into the port than number 5 does. Now, that was to give it a little bit better start going into the port, okay, and give number 1 a little bit more flow. Did it work? Yeah, it worked, but it didn't make a huge difference. Now, what I did was I went in and I cleaned up every port, okay? Every port got cleaned up. And then from there, I measured the flow that we got from the cleaned up. And then we went on to balancing. So let's take a look at the sheet. Okay. So if you look at the top, this was completely stock. 338, 333, 343.6, 344.2, 341.3, 337.1, 343, 333.8. Okay. And then from there, went on to port every single one. So they all went up. We went from 338 to 340, 333 to 342, 343.6 to 350. That was our biggest, that was our highest flowing port. 344.2 to 347, 341.3 to 346, 337.1 to 346.5, 343 to 345, 333.8 to 333.8, 333.8 to 338. Okay. Then from that point, I tried to equalize them. And I simplified it. I didn't use all those flows on here because it's just nuts. So I kept the sheet separate, and I added them when I was completely fed up and said, all right, well, this is how it's going to be, because that's how it works. Okay? 340.3, 340.6, 349.4, 347.6, 346.6, 346.4, 343.6, 339.4. Okay, so if we take a look at this, we have a discrepancy of 10 CFM. Now, the problem with an intake manifold like this is it's designed pretty good from the factory. So whoever they had looking at it did a pretty good job. Let's take a look at how it's a little bit unorthodox design, but I like it. It's a little unorthodox. If you take a look at the end runners, that divider, right? They kick that divider all the way back. Let me put you on a little bit of an angle so you can see it. See how they did that divider? I don't know what that does to your pulse reflection, but it makes it a lot easier for the air to get in on the bottom of those ports. If you brought that wall straight down, there would be no room. There would be real narrow at the bottom. So I kind of like how they did that. Right? They moved it back and they kept it relatively wide. The short ones are easy, right? The short ones, piece of cake to get flow down. What I actually wound up doing is, if you pay really close attention, take a look at the one on the left. See how sharp I made that edge? We'll leave that as a question too. Why do you think I would remove part of the radius and actually leave it relatively sharp at the bottom of that one and the bottom of that one? They're not the same. They're not the same. One had more. This one is the sharper one, right? what would be the purpose of doing that, guys? See if you can figure that out. Now, as far as the dividers at every port interface, I have to take a look at which port flows better and which one flows worse, and then I have to bias it towards the one that doesn't flow as well. Obviously, I think it's fairly successful, so I'm pretty happy with it. Okay, now this is a huge manifold, but the runners are quite long because it's really tall. I mean, if you look at it this way, look at how tall this thing is. This is a monster. And by the time you put a spacer on it, which I'm pretty sure I would probably run it with a spacer, and then a nitrous spacer, and then the carb, this thing is going to be real tall. Real tall. All right, we'll just take a look at a couple, how they turned out. I really like this manifold, but if you take a look at the new Hollies, the Hollies, they split in half. They unbolt so you can get to them. I've actually got two of them. I got a rectangular port and I got a cathedral port for LS stuff and storage that I'll have to dig out and show you guys someday. They are designed really nicely, and because they come apart, they're like a dream to port. This is not a dream to port because the runners are so long. I've been looking for 9-inch burrs. I have zero luck finding 9-inch burrs. If anyone has a connection to get 9-inch burrs, let me know where they are. Hold on a sec.